I hope you can see and hear. Say if so.
Yeah, it's working. There you go.
Cool. I'm actually surprised it worked. I'm sharing OBS window to compose the webcam and the presentation the way you see. And that background is actually Spelunky PSP window that I'm running. It's obviously a special build with much larger viewports to fit more stuff on the screen. And well, it's quite late in here, so expect brain farts. And getting to the presentation itself, I tried really hard not to make it too technical. The reason being, if you are interested in the development details, you already have my devlogs that I put on YouTube, and the code is publicly available on GitHub, so go and see it if you wish. However, in this presentation, I'd like to present, let's say, a list of conclusions that came after the first year of development. But I didn't introduce myself yet. My name is Daniel, and Spelunky PSP project is an effort to recreate a game called Spelunky Classic, made by the RQ in technologies such as C++, OpenGL, and CMake. And I say this formula in the beginning of each devlog, and I say it now because I want to emphasize that it's a completely separate entity that shares only the assets with the original game. Assets such as textures, sounds, music, and fonts are taken from the original game, as Spelunky Classic license allows it, as long as it's not done for profit. However, the problem with the original game is that it is made in Game Maker, which means that you can't build and run it on some retro platform unless Game Maker starts supporting it, which is very unlikely. However, by recreating the game in commonly adopted technologies, it is possible to run it not only on PSP, but pretty much everywhere, the only real limitation being the computational capabilities of the target platform. So, I was just thinking of cross-platform capabilities. So how many platforms are supported at this moment? Well, obviously PSP, but not only PSP, because supporting a generic Linux platform was a must for development because I needed a debugging environment. Truth is, the most of bugs you introduce when writing a game is platform dependent, and those are your game logic bugs. For example, off by one errors or the reference null pointer, and those can be reproduced everywhere. And Linux was actually that convenient that I rarely run Spelunky PSP on a real PSP, pretty much only upon each release when I had to actually test it, because most of potential bugs were already detected on desktop, on Linux. And as a bonus, by supporting a generic Linux platform, I could run Spelunky PSP on such devices as Raspberry Pi and Orange Pi. Here on this video, I'm running it on a Raspberry Pi 3 without the X server, using software implemented OpenGL and displaying it on a tiny 1.8-inch display. Native support for Windows was a low-hanging fruit. However, if you are already on Windows, there is no reason for you to play Spelunky PSP instead of the original Spelunky, so this platform is pretty much only a demonstration of cross-platform capabilities of this project. And coming to the next platform, and this may surprise you, Android. And yes, it's still built and run from the same C++ code base that is used on PSP and Windows and Linux. The only difference being that there is a Java activity shipped by SDL that calls my main function through JNI, Java Native Interface, but this is transparent from C++ codebase perspective. It doesn't even notice it is called from Java. There's one drawback though, that only physical keyboard is supported, meaning that you have to connect one through, for example, USB on the go, because there is no on-screen controls. I just didn't want to focus too much on Android, so again, it's only a curious example of cross-platform development. And the last platform that I tried to support but ultimately failed is Pocket Go. If you don't know it, it's a Linux-based device with 32 megs of RAM and a pretty obsolete ARM processor. The major difference comparing to the PSP is that there is no GPU. Well, PSP has a GPU, Pocket Go doesn't, and Spelunky PSP utilizes OpenGL. So what I did as a workaround was introducing so-called software-implemented OpenGL, meaning that the CPU would act as a GPU. And I dedicated a separate long video about it on my YouTube channel if you are interested in the details. However, what I end up with this solution was around 1.3 FPS, which is nowhere near playable. It literally took around 700 milliseconds to render a single frame. However, I'm still quite proud that I at least run and displayed it on such a device. And maybe in the future, when when the game is feature complete and when I have time for such experiments, I may try to re-implement the renderer to not use OpenGL and rather use simple pixel splitting, for example, shipped by SDL instead, because OpenGL adds a lot of abstraction over displaying, for example, through vertices, matrices, indices, and it may be just more efficient to do simple pixel copying. Yeah, and supporting even 8,000 platforms would be useless without the actual gameplay, without the in-game features. So in terms of functionalities, what is implemented so far is NPCs, for example, bats, snakes, spiders, cavemen, skeletons, arrow traps. There are also items like pistols, like shotguns, like ropes, bombs, whips, chests, jars, rocks, and probably many others that I forgot. There are also collectibles like diamonds, gold bars, gold chunks, and there are particles like blood particles, like smoke particles. So right now the game is already roughly playable. There's one catch though, that in the most recent 0.4 release, the main dude can't be hurt by NPCs, which is, believe me or not, intentional, because the last release ships already multiple features and I just didn't want to overstretch myself over too many of those. And just to show you what I started with, here's a video that I recorded shortly after 0.1 release, around a year ago. And notice how even the camera doesn't follow the main dude. What it was back then was maybe a cross-platform tile renderer, but nothing more. So, what did I learn throughout this first year of Spelunky PSP development? So here's my setup throughout the year. What was my motivation for coming up with this Spelunky PSP? Well, part of my motivation was to expand knowledge. I wanted to learn more on C++, CMake, and OpenGL because it's simply in my field of interest. And what I'll always say, there's no better way of learning a technology than writing a game using it. But it's not only technologies that count, there's also a lot of design patterns that I learned and applied when writing Spelunky PSP. And design patterns are language and kind of software independent, because I will use them even if at some point of my life I decide to write microservices in Java. And learning them is a life changer. There's actually a book that I want to recommend. It's called Game Programming Patterns by Robert Nystrom, and it's basically a list of blueprints that you may apply in your code base. And I applied almost all of them. I think only the ones about spatial partitioning are those that I didn't use, because it would be an overkill in a game of that small scale. But nevertheless, it's a great source of inspiration. Part 2 of my motivation was remotely work related. You see, I have no formal education in computer science, so I'm trying to compensate for it, or else securing a programming job would be much harder. And having a portfolio of hobby project is a good way of showing off. Same goes for the YouTube channel. It's a way of showing off and a very satisfying one. And time constraints. I already have a full-time job, so that means that only the weekends are the days that I can commit to the project. So most of the code I did was done on weekends, and it really sucks getting back to the code that you wrote the week before. But even the weekends, even the days I could commit weren't always possible. The reason is I'm not a robot, so sometimes I had just other activities to do. And coming to the actual lessons learned after the setup, well, lesson number 1, discipline is everything, because it turns out that putting 1 or 2 days a week consistently is enough to have a working project after a year, and the key is to have realistic time expectations and, ironically enough, take your time. And that's also the title of the next lesson. Take your time, because one trap that you may fall into when having short time resources is to develop hastily, and in short term, yes, you'll get into something semi-working really fast, but in long term, the development will become tedious and you'll abandon the project because it won't bring joy anymore. So if you feel tempted to do shortcuts in designing software, don't. I say in designing specifically because, well, when doing the actual implementation, when writing the code, we all tend to do shortcuts from time to time, some small code here and there, some unoptimal algorithm or whatever, but those are pretty harmless after all and easy to refactor. However, the design mistakes are, well, they tend to stack up. So before you get the keyboard into your hands, get a pen and a piece of paper and think of what you're implementing. And yes, it may sound truistic and cliche, but a long time passed before I myself actually made it into a habit, into a ritual that has to be done before I even sit to the computer. And the next lesson, share your project. The development logs that I record are the vehicle that I use to reiterate over my progress, to summarize what I did, maybe to plan what I have to do next. And this is what I consider important because it's an incentive that keeps you going. Sharing your project and seeing that it's probably followed by someone, someone watches it and probably even enjoys it. It really boosts motivation and keeps you going. So take my advice and share your project from time to time. I know some of you have Discord channels dedicated for your projects. In my case, it's just more convenient to record a video. And the last lesson, distract yourself, because distracting is refreshing. Was adding native Android support helping developing the game itself? Did it boost the game mechanics development? Obviously not. Was an attempt to support devices without the GPU like Pocket Go helping development the game features? Absolutely not. However, the attempt to aggregate all the small bits of know-how on software or implemented OpenGL scattered around the internet was a very satisfying one, and in the end it helped me because I was still interested in the project. It wasn't a new project that I started a side project within a project. Yeah. So what are my plans for the next release, for the next year? What I'm aiming to is being feature complete compared to the original game, which means implementing the cave level, the lava city level, the jungle level, the final boss, the damsel, the shopkeeper, everything in between, all the missing items. And this may sound a little bit overambitious and overpromising because getting up to this point took me over a year, but considering that most of the time I spent so far was on the game framework, not on the game contents, it may be actually realistic to expect me to ship those new features, because doing the actual in-game contents once the framework is set up is much easier. In any case, wish me luck, and that would be all. A link to the GitHub repository is on the slide. Link to the devlogs are in the README. If you want to download a pre-made artifact that you can drop on your PSP, they are included in the Releases tab on the repository. And if you want to report a bug, please do so through the Issues page on the same repository. Thank you, and it's now time for questions, I presume. Could you repeat that, please?
Do you also own a Pocket Go 2?
Pocket Go 2. I'm not aware of this device, but if it has a GPU, I think I can support it straight away. However, problem with this software implemented OpenGL is that it is very CPU consuming, and maybe if I put some optimizations in the Spelunky PSP code base, like I have a few on my mind, for example, the greedy meshing that I could apply on the tile map, meaning that I could drastically reduce number of vertices. I could actually also apply spatial partitioning plus frustum calling, so the map would be split into pieces, and depending on which of these pieces is in the camera frustum, I could I could conditionally render only part of map, but after all, those optimization may be inadequate to the power this device has. Pocket Go is really not a powerful device, so I believe only rewriting the renderer to use simple pixel splitting may be the solution, and it may actually work on Pocket Go. I hope that answers your question.
Yeah, thank you. Question in chat from Connor. When everything is finished, do you plan on porting it to the DS, GBA, or 3DS?
Truth is, I already wrote Spelunky for Nintendo DS. It's a project that I discontinued today. I discontinued it in 2018, I think, and it's actually a project that I used it as a sandbox, as a playground for learning C++. Problem with Spelunky NDS, which you can find on my GitHub, is it became unmaintainable, first of all, because, well, imagine a person that learns a new language and this person decides to make a project of this scale, and it's his first encounter of C++. And second reason is Spelunky PSP is designed to be cross-platform, while Spelunky NDS utilizes a very custom NDS-specific calls because, well, NDS has this hardware that NDS has a dedicated piece of hardware for rendering tile maps, which is not portable. So I decided I would just rewrite the code base using all the best practices I learned so far and using the commonly adopted technologies by mean, for example, OpenGL as a rendering API, C++ as a language, CMake as a build system. So yeah, this partially answers your question. Spelunky is already available on Nintendo DS and all the other DS family consoles because I already ported it. file structure? For example, do you mean file structure inside the project as sources, as source files, or I can actually show it. Just give me a second, literally a few seconds. Anyway, I could answer to this question in two ways. The first one and easy one would be just watch the first episode of my Spelunky PSP development series on YouTube. But the second way would be to actually go through the project here in this presentation. I'll just change the window that I'm sharing. Just 1 second. All right, so you should now see CLion. So obviously there's a root CMake file. I'm adding all the subdirectories. Obviously there's a vendor directory to which I put all the third-party stuff that I may want to use. For example, the entity framework or GLAD for OpenGL. Let's just see what I have in the vendor directory. I have CJSON, which is a library for parsing JSON files, entity, GLAD, GLM, logger, and STB, because I think I use STB image. Yes, I use STB image. So besides that, I have multiple folders where I logically put each part of the code base, which is kinda standalone and can be placed on itself. I know how much time can I commit to this walkthrough through the code base, so I'll just show you. Well, obviously there's a main function where I init the singletons here, and then I get to the game loop. Yeah, and one thing that you may be interested, how do I deliver the assets, for example, images or sounds? I do resource compile them, which means that I have a small tool course called Resource Compiler, which is a really small program under 100 lines of code, well, slightly above it, which takes an arbitrary binary file and it outputs it as a header file that you can include in the code base, with all the bytes of this file encoded as an element of a char array. And that makes me independent of the file system of the target platform. Anyway, I think I can talk about this forever, so because of that, I just so I'll just constrain myself.
Well, thanks. That was a really informative presentation. I loved the format with the webcam and everything.
Thanks.
Well, up next we have Tour of Light by Chan Chu Chu, and I believe that's a